Hi everyone, welcome to this stream. My name is Romain Fromi and I am the founder of GamePark, which is a board game online website. On GamePark, you can play board games with your friends or with strangers in real time. And the rules are enforced. So today I want to show how you can add a new game if you want to contribute. I am always looking for, new volunteers to implement games. And so we will show today with a very simple game, which is called Ultimate Tic-Tac-Toe, a few steps on the way to create a new board game. So I'm here today with Benjamin on the Pusher Dev channel.
Hi, everyone.
And I would like to thank you, Pusher, for first, making GamePark possible. I will explain how I use Pusher behind the scene after the introduction, and to host this stream today as well. So yeah, first, my developer journey. Very quickly, I've been working as a software engineer in France and also in Switzerland for 10 years. And a few years ago, I founded GamePark. I wanted, to own my own project and share both my passion in software engineering and board games. So as I said, GamePark is a website. On this website, you can play in real-time board games. Today, we have already 9 games online, and we will code a new game live today, and I will deploy it also a few weeks later. So today we will be building the ultimate tic-tac-toe. It's like a tic-tac-toe game. It's a very simple game. You just have to align 3 marks in a row, in a line, in a column, in a row, or in a diagonal. In Ultimate Tic-Tac-Toe, instead of having just one grid, you have 9 grids, and you need to win the inner grid to gain the game, which is the meta grid around the 9 grids. So you also have a constraint in placing your marks depending on where the opponent has played just before. We will discover this when we implement the rules later on. So I chose this game. It's a simple game, yet interesting game. This way we can implement the game during the small hour of this stream. Of course, the GamePark API can also handle much complex game and has options to handle random moves or private information and so on. So regarding Pusher, I used Pusher to build GamePark, and I needed Pusher because, I created a stateless server. It's important for me to have a stateless server. This way I can, scale a lot. If tomorrow I have a lot of players for, a short period of time, where it's hosted, it will scale automatically. However, with a stateless server, I was not able to handle WebSockets myself. So that's where Pusher comes, in play. With Pusher, I'm able to send real-time notification to the players in every game, both public notification and private notification. And so it's just fitting perfectly for my use case. So if you want to code along with me today, you need to have Node, Git, and Yarn installed. You also need a code editor. I will be using WebStorm, but you can use VS Code as well, which is a free one. And if you like, you can check out the repository right now. The link is also in the chat. And that's it. So the walkthrough of solution quickly. First, I will show you how the project is structured. Then I will show how you can create a new game, how you can start a new game, how you can display the initial game state. Then we will play our first move. Well, we will first implement how it's played, and then we need to implement a little bit the rules of the game to make it legal. Because as rules are enforced, you cannot play anything you like at any time on GamePark. So let's implement. Oh, as well, if you have any questions, feel free to interrupt, to ask the question in the chat, and I will be very pleased to answer it, of course. So here is the ultimate tic-tac-toe project. Any game on GamePark a game is always made of two parts. We have the app part and the rules part. The app part is a static React application. It's the user interface of the game. And the rules part here, it's a node module. It contains the rules of the game. It implements the GamePark rules API. And this module will both be embedded on the GamePark server to enforce the rules. And also it will be used on the app side. And this way we can create, a very nice user experience. For example, if you want to play a move, the user interface will tell you if it's legal or not, even before you will play it. You don't have any latency. You don't play the move and then the server tells it's not legal. No, it's already displayed on the user interface what you can play or what you cannot play. So you are guided. So let's start with, the first step. When you implement a game, you need to implement a rules class. So this class, Ultimate Tic-Tac-Toe Rules, contains all the rules of the game. We extend the rules abstract class from the GamePark framework in the rules API. And it's a generic class, and we need to pass our specific game state, our specific moves, what moves exist in this game, and what is a player identifier in a game of tic-tac-toe. So in our case, we just have, X and O, the marks of the player. It's a very good player ID. We will implement our first move later on, and we have the game state here. So the first thing you need to do when you implement a new game on GamePark is designing the game state. So here for the Ultimate Tic-Tac-Toe game, I already added this property, the game board. And in this game, let me show you again how it's done here. Yes. So in the Ultimate Tic-Tac-Toe, we have an array of mark or null. So when a cell is empty, we have null. Otherwise, we have a player mark, X and or O. And I used a 4-dimension array. It's one way to do it. You can use a 9x9 array if you like. It will work. Or you can use a 3x3 array and another array of 9 of those grids. I chose this way to do it, so an array with 4 dimensions, because it will be simpler to implement the rules later on using this solution. So yes, you have this type. It's what a game state is. It's the data structure of a game state. Then, when a new game starts, you have the constructor of your rules class, and the constructor can handle either, starting from a new game. So sometimes you have game options. In this game, it's not relevant. And you can also have a saved game that you restart from. So when you start a new game, you have this constructor. Either we have an existing game or we need to create a new game. So in this case, you have a new game. You need to start with a board full of null. So I have created an array of 3 rows of grids. Each row has 3 grids in it. Each grid has 3 rows of cells, and each cells have 3 times null for a start. If you want to see what it's like, then you need to start. Well, first you need to install the dependencies, of course. If you're not familiar with Yarn or with node.js, well, you need to run the yarn install command to install all the dependencies you need to implement the game. So the dependencies are inside the package.json folder. It's the package.json files here. It's already there. It's already there in the bootstrap of the project. So once installed, you can run yarn start to start the React application in the local mode that will allow you to run against opponents that play random moves. It's very convenient for the development. I already displayed one tic-tac-toe grid with random marks just to fasten the development for the stream. So once you created your initial game state, you want to display it. So the first thing you need to go in is inside the app. So it's the React application. If you're already familiar with the React, we have a classic structure with index.tsx. It's we use TypeScript on the project, and we have the app component, which is the first component of the application. This one has some generic components that creates, for example, the GamePark menu here, or the header, and so on. And then you have the game display, and we will work inside this component, game display. Once the game is loaded, we display everything that is going on inside the game inside this component. So right now, I already created a grid component to display one grid made of 9 cells. So we have a grid, we map twice on the grid rows and columns to display the cells. And inside game display, for now, I only showed one grid, and we have arbitrary marks in there. So when you run a React application locally, what is very convenient is that if you change anything in the code, for example, here I put another mark here, it will be reloaded automatically and the new state will be displayed immediately there. That's very convenient. And well, the first steps now for us is to display the initial state of the game. So the 9 empty grids that we have when a game starts. We already, thanks to the GamePark framework, we already have the state of the game. Here we have a custom GamePark hook use game that retrieves the game state and the game display. Well, once the game state is loaded, because when we will be live, we need to load the game state from the GamePark server. So once it's loaded, the game display component is displayed, and we have here the game state. The game state, which is made of a board, and our board has 4 grid row, and every grid row is made of 3 grids. And well, the grids can be displayed using this grid component. So we can display, so right now I will erase the hard-coded first grid here. And we will show the result. So it's right now it's empty. Let's start a new game. Okay, so we have one grid displayed here, only one grid. That's because our 9 grids are actually on top of each other. In GamePark, we use absolute positioning for everything because we want our application to be responsive. And we want it to be responsive without coding, taking a lot of time to, adapt the user interface to mobile, portrait mode, landscape mode, any size of screens, and so on. So what we do is this approach comes from every mobile game development. We use landscape mode, and we use the letterbox pattern. We put ourselves inside a letterbox, which is a 16 per 9 element, and everything we display is inside this component in absolute position and with absolute size. This way is very convenient to create a user interface that will automatically scale up with the screen. And we just have to make sure that everything is large enough to be displayed on a mobile in landscape mode. Or if it's not large enough, we need to implement, a click and enlarge action on the component. For example, the first game which is available on GamePark, It's a Wonderful World. If you click on a card, you get a bigger version of the card that is displayed so that you can, read if you have any text on it. If it's too small on a mobile, you can see it in full screen mode. So let's go back to our grids. We have a grid position here. It's a CSS instruction. We use the framework called Emotion for the CSS. And right now, the absolute positioning here, it's top and left. It's always the same position. So our 9 grids are on top of each other. What we want to do is add a row and column on our CSS. Well, our CSS will become a function that depends on the row and the column of the grid we want to display. And here we can say it's displayed at row times, for example, 30 em, and the left instruction will be, well, the same. Up will be, of course, the column index, and the left will be the row index. So with this grid position, we can pass here the index of the row and the index of the column inside the grid. So each grid row has a row index, of course, and each grid here has a column index. So that's the map, the standard JavaScript map function. And we can pass the row index and the column index directly to our grid position. Once we do that, well, we have our 9 grids. Right now it's ugly because 30 is not enough. Maybe 33 will be better. And that's it. We have our 9 grids. We are a little bit off the screen here. So what we need to do is we need to shorten a little bit the grid. So I will go inside the cell component at the lower level, and I will decrease the cell size to 9. That's it. And now my grids can be a little bit smaller, a little bit smaller, yes. So 30 and 30. Yeah, that's it. So we have our 9 grids displayed right now. And well, for Ultimate Tic-Tac-Toe, that's the initial game state. That's not very interesting, of course. Maybe we can show if it works or not. So what we can do here, we can for now hardcode maybe one mark inside the grid and see if it's displayed properly. So we can do new game dot board. We can, well, let's take the first line, the second column, and there we can put in the middle of this grid, we can put a mark.x. Okay. It won't show up right now because the game state, when a new game is created, the game state is saved in the local storage of the browser. This way, you don't restart from, an empty game every time you change one line of code. It will be very hard to, test what you are doing if you get a new game state every time you change a line. So what we have to do when we change something in the, in the game state, or when you add something in the game constructor, you need to call this command from the GamePark API in the console of the browser. You can do game.new to create a new game automatically. And now we can see that we have the X mark that we added during the setup of the game, which is displayed. We also have a warning here. So that's a React warning. Every time you use in React a map to display a list of components, you should add a unique key to identify the component that is, to identify every different grid here. So a good identifier here for the grid is, you need, for example, the row index. So yeah, let's create a string. Inside this string, we will have the row index and the column index and a separator in the middle. So row index, okay, column index. That's a unique key, and if we refresh, we won't have this warning any longer. So we have displayed the initial game state. We know that we have the X and O marks that will be displayed, so we can also display some O mark somewhere. Okay, so we have the marks displayed, but we cannot play any move yet. We only have the initial game. Now we must implement, well, how you can play a move in this game. If anyone has a question, of course, feel free to ask. So I will erase this. I will create a new branch called stream because we just completed the first step of our tutorial. And well, new game state, or start a new game, start a new game. Okay. So the second step of this tutorial is how we can play a move. So when we started, I show you that when you implement the rules, you have the structure of the game, and you also have the structure of the moves. On GamePark, every move that a player do, so every decision he makes, is saved in the database. This way, when we want to replay a game later on, well, you have all the history of the game that is saved in the database. And it's also very useful if you want to implement some undo features on a game. It's often required for a complex game with complex actions for the players. It's very convenient if the players can undo the move because, on a user interface, you can always also misclick and do something that was not intended. If you can undo it, the user experience is much better, of course. So, because each move is, saved in the database, every move must be described using a data structure. This pattern is the command pattern. When you have a move, you have a data structure, and you can play the move on the current game state. And the game state will go from the, initial state to the next state. So what is a move in a game of tic-tac-toe? In a game of tic-tac-toe, we need only one move actually. We need mark cell. Marking a cell is the only relevant move in this game. But if you implement a complex game, you can have 10 or 20 different moves. Every move represents either a movement of material, a concrete movement of material around the table, or it can be also when the rules is contains many consecutive game phases or stuff like that, or if you need to change the current player, you can use a specific move for this kind of actions. And sometimes you also have a move where the player must make a decision between two options, for example, two effects on a card or something like that. So you have also moves that are pure decisions between options. All those situations make for good moves to implement when you implement a game. In this game, we will only have one move, mark cell. So we need a data structure. So let's create a new TypeScript type for this move, mark cell, and let's export. Let's export it, mark cell. Okay. When you mark a cell, you need to say which mark will go in there. You need to say which grid it will be. So maybe we can use X and Y coordinate to identify the grid we will mark in, and we can use A and J coordinates to identify which specific cell inside the grid we are marking. So we have a 4-dimension array. We can use we need 4 coordinates to identify what cell we are marking. Of course, all that is if you want to implement it another way, or if you want different names, you can use different names. Here I chose very short names because every move is recorded in the database. So it's my choice to use short names because in the Mongo database behind the scene, it will be shorter. It will take less space in the database. So this data structure, we won't need it because it's a data structure you use when you have a lot of different moves in the game. So what I will do is just replace the move here with our single move, which is mark cell. And I need to change it there as well. Okay. I can delete this. Okay, I need to change it there as well. Now I can delete the old moves class and just use the simple mark cell move. So in a game of tic-tac-toe, you have the move which is mark cell. This function, the play function, is the only function in GamePark API where you are allowed to change the state of the game. It's the only way you can change the state of the game, because every movement, everything that happens in a game must happen through a move, and the move will be automatically played by the GamePark API. For example, during the replay or undo feature, we need to use this play function all the time to play the moves. So when a move is played here, all we need to do is to change the grid. So we will take the game state, the current game state. So this dot game, when we have a new game of tic-tac-toe, we call the parent constructor, the rules constructor, and this constructor will only store the current game state inside the class. So it's available here with this dot game. So we have the current game state. We have the board. We need to take, the first row. So the first row will be accessed with move.y. Then the grid inside the row will be move.x. So it's a convenient way to use this. We have the x-axis with this horizontal axis and the y-axis, which is the vertical axis. So we need to access x then y inside the array, and we will do the same inside the grid with j and I, and we will put move.mark. Okay, so now we have implemented the move, but we have not played it from the user interface yet. To play a move in GamePark, you have a hook which is available in the framework, which is called usePlay. usePlay, it returns a function that will play a move. It will play the move following all the GamePark logic that takes care of playing the move on your local machine. That will also send the move to the GamePark server, and the GamePark server, through pusher, will send a notification to every other player and spectator on the game, and every player and every spectator will also play the move automatically on their local, their local computer. So if you want to play a move in GamePark, so I want to play this kind of move, I just retrieve, using the usePlay React hook, the play function. And, well, let's see. If we click on a grid, so we have onClick, which is available here. Maybe I can play the move, which is mark cell. I can say the mark for now is X, and let's say that Y is 1, J is 1, X is X can be the column index, and Y can be the row index. Just want to show you right now that with this, we are already able to play moves. We hard-coded some stuff yet, but we can already play a move. So if I click on a grid, the X mark will appear right at the middle of the grid. So it's very efficient because everything is taken care of by the GamePark framework. However, if you look at the console, this move is not authorized right now. Right now, we just implemented what the move is, playing the move, and how the move changed the game state, but we didn't implement the rules of the game yet. So the GamePark framework is not allowing random moves like that. So before we continue, I want to play the move inside the specific cell that is clicked. So let's do this. When we click on the grid, clicking on the grid is not very interesting. What we are interested in is clicking on a cell. So we need, when you click on a cell, you need, well, not this, not there, sorry. When you click on a cell, you want here onClick to play the move. The onClick function is not available on this component. This component only has a cell attribute. What I want to do is allow every HTML attributes of a div element so that I can, configure the div square that is used to represent the cell from the outside. So it's a classic way to do it with React. I can just retrieve all the properties that are passed from the outside and just repeat it on the div that is at the root of my component. I already used this trick on the grid component there, and it's convenient to pass the standard HTML attributes and CSS properties too. So no onClick is available here. And when we click on a cell, we can call a onCellClick function, maybe, and we can say what was, the row and the column of the cell, which was clicked. So here we have the row index. Here we have the column index inside the grid. And on cell click, we can pass the row index and the column index. To do that, we need to expose inside our grid component the onCellClick function. So we will say that our component has an additional property, onCellClick, which is a function that returns void. And this function takes the row index and the column index as attributes. Okay, so we declared it in the property. That's the types of our property. We extracted it when we have a new grid component, and we used it when a cell is clicked. This way, on the upper component in game display, we will be able to use the onCellClick function here. So we have the cell row index and the cell column index here. And the cell row index will be our A coordinate, and the cell column index will be our I coordinate. Okay. Let's test it. So with this code, we will be able to mark specific cell in every grid. So as we can see, it's working. It's working, but it's still not authorized in the GamePark framework, of course. As you can see, we are marking, we are only putting X mark. It's also hard coded for now. So what we want to do is marking using our own mark. What you can do is use another React hook, which is use player ID to retrieve the player ID representing the player you are playing right now. So with this hook, you will get either a mark, the mark of the player which is playing, or undefined because, well, spectators don't have a player ID. So you have a player ID which is undefined as your mark, and you can say when you play a move that, well, player ID is your mark. Of course, it's not working because here you cannot assign undefined to a mark. When you play a move, you want a mark, and of course, spectators cannot play any move. So what we can do is check if we have a player ID, which is not undefined. So we check that we have a player ID. If we have, we just run the play function with the move. Okay, and well, one interesting note here, your player ID is O. It's a random attribution when I start a new game with the GamePark framework. You have a random player ID when you debug your game. So now I will put the O mark. If I start a new game, maybe I will be X at some point, so it's random. Lucky. Okay. Okay, now my player ID is X. If I just put my mark, I put the X mark. Still not authorized. But right now, when we play a move, it's not hard-coded at all. Maybe we can commit that. Playing first move. Okay. So what we already have here is how you can play a move inside the React application, or you can send a move in GamePark framework so that it's played locally, but it will also be played on the server and on every other player's machine when the game is live. And the way it affects the game state, it's just implemented inside this function in the GamePark API. Thanks to React and thanks to the GamePark server, the update everywhere on the user interface of every player and inside the database of GamePark as well is automatically handled. As we said, the moves are not legal. That's because we need to implement this function, getLegalMove. Well, we have two options. We can implement another function which is legal for a move. But if we do so, we won't be able to run dummy opponents. On GamePark, you play against other players in real time. Sometimes they are strangers. And if they, leave the game, if they rage quit the game, for example, or if they lost their internet connection, well, that's bad. You won't be able to complete the game, even if you just have just a couple of moves yet to play. To avoid this frustration, what we do in every game on GamePark, we implement dummy opponents. The way we do it in most games is using this function, getLegalMoves, which will list every move that is allowed in the game at any point in the game. Some games, that's not possible because it would be, there are too many options. In that case, we fall back on this function and we create a dummy AI to replace any player that is left. Another good stuff with this function is when you are in the local development mode, we will be able to start monkey opponents that will play random moves against you so that you can really quickly, test and debug the game. So legal moves. We need to return the list of every mark cell moves that are allowed when you play the game. So first, we want, we want an empty array of moves. Okay. We will return that. And then we have this.game.board. For every row, grid row inside the game board, for every grid inside every row, inside our grids, we have rows of cells. So we have a row here, and inside the row, if we iterate on a row, we have finally a cell. All these loops I will change for indexed loop this way. Okay, so this is our columns. So we can use Y. Here we have X, the rows. Here we have J, the inner grid columns. And we have Y, the inner grid columns index. So, and the cell is here, of course. Yes. So we can add to the moves push. Oh, sorry. A move is an array of mark cell, of course, the moves. So we can push inside the moves. The mark will be your player ID. So of course, get legal moves must return the legal moves for a specific player. If the player is not active, of course, we must return an empty array. He has no legal moves. We will do that later on. First, we will allow any player to mark any cell at any time for a start. And that's done very quickly with this for loops. Okay, for every grid row, for every row and for every cell, we have a legal move, which is put your mark at these coordinates. Now, if we test, so if I mark a cell, okay, so what we have here, the move now is legal. You can put your mark in any cell and it's legal, and because it's legal, it will stay in the game state. If I reload the screen, the mark is there forever. Okay? Of course, you take turns in a game of tic-tac-toe. So when it's not your turn to play, well, you should not be able to mark any cell. So what we want to do, we want to change a little bit the game state, and we want to put the current player inside the game state. This way, we can identify which turn it is to play and return no legal moves for the other player. And we will implement this function, which comes from the GamePark framework. You have different kinds of games, different kinds of board games. You have board games with simultaneous actions. That's a game where players can play and take actions simultaneously. And you also have games where it's always one player at a time, which is active. When you have only one player active at a time, you can implement this function, getActivePlayer, which is very convenient. It will automatically handle a few stuff for you. So in our case, we have the active player. Maybe we can call it active player. We have the active player inside the game state at any time in the game. And when we start a new game, that's in the rules, it's always X that starts. So the active player in a new game is X. And now what we can do is, if this game active player is not your player ID, well, we have no legal move. So we just return an empty array in this case. We only return that, okay? Of course, we added the active player, but we didn't change the active player at any point. We need to change it every time a cell is marked. So this game active player equals, well, if the active player was X, it's now O, otherwise it's X. So we change the active player this way when the movie is played. Okay, now very interesting. We have a game state that is stored inside your local storage. And this game state is completely obsolete right now because it contains a data structure without an active player. Every time you change the game state, you need to start a new game. Otherwise, you have a game state which is incomplete, which is incoherent with your new data structure. So yeah, new game. Type active player. Oh yes, another issue. That's a small issue with React and the hot reloading. When you change a file that, for example, I change this file and it doesn't contain any JavaScript code. It contains only TypeScript typings. Unfortunately, I need to restart the application and the hot reloading because this file was not followed by the hot reloading tool. So I need to restart. And now I can start. Well, I have a new game. And if I try to put my mark, right now I am O. If I try to put my mark, the move is not authorized right now because it's X that is the active player. You can use this command game state here to see the actual game state. The active player is X. And you can use this command game.monkeyOpponents to have an opponent that will play random moves against you every time it's their turn to play. So using this, my opponent just the next mark on the grid, and now it's my turn to play. The move I played here when it was not legal was not persisted in the database because it's not legal. And it's your responsibility to prevent it from being played at all in the user interface. So now I can play, and you can see that my opponent is marking a new cell every time. Well, we have other constraints to implement. For example, I can erase my opponent's mark because I didn't forbid this move. So we have other rules to implement. And well, I can see it's already, we are nearly past the time. So I don't know if I should continue or not. Maybe Brittany can tell me. She's hosting the stream. If I should maybe continue, or if I can maybe show you a little bit about Pusher first before we continue. How Pusher is used behind the scene. Maybe I can do that. We just have the beginning of our implementation. I will commit what I just did. So moves and active player. Okay. And maybe I will stop implementing the game rules. I already showed how it's done with GamePark framework, at least the beginning. Implementing the rest of the rules is also interesting, but of course it's specific to the game, and it can be done well maybe in another hour at some other point. But maybe right now I will explain you a few stuff about the GamePark framework and about how Pusher is used also behind the scene. I think it will be quite interesting. So what we have here with our game, when we play a move, behind the scene, it's immediately played on your local browser. And it's also sent to the GamePark server using a classic HTTP request. On the GamePark server, the game, we will check if the move is legal, of course. It must be done on the server, otherwise the security is not right. And once the move is legal, it will be played, and we will send a live Pusher notification to every other player and spectator that are playing the game or watching the game at the same moment. This notification contains the move that has been played, and every other player and spectator will play the move locally using the rules API that we created. So we do not send the new game state every time a move is played. We just send the move to everyone, and everyone is playing the move on their side every time they receive it. That's fine for this game, the Ultimate Tic-Tac-Toe. But sometimes in games we have private information. Private information, for example, it's when you have a hand of cards, you know what is inside it, but the other player and spectators does not know what's inside your hand. So in that case, when you draw a card, for example, you need to receive the move, but the other players and spectators need to receive another move, a move which does not contain the information about which card you just draw. So in that case, we have game with what is called private information. We have a specific API to implement those secrets. And when we have private information, we use Pusher in a different way. We use Pusher private channels to send the private information to every other player, to every player in the game. Every player has their own private channel to receive their private information about the game. And we also have a public channel for the spectator. So we also send, public information, what can be seen by anyone on the game through a public channel. And it's quite simple, actually, the implementation. It's here. So every time on the GamePark server, we need to send public notifications. Well, we just retrieve all the notifications. So a notification can contain moves that are played or moves that are undone. And when something is done, maybe we have more than one move played at once. So that's why we have a list of notification. But anyway, for every move that is played, we will send, using pusher, we will trigger a new moves played event using a public channel. The channel is the identifier of the game. And if we have private information, then we will send private notification to each individual player. And we will also send one public notification for the spectators. So that's how pusher is used behind the hood. It's as you can see, the implementation regarding this part is really simple. Of course, inside the GamePark API on the client side, we also have the pusher client part that will, register on the channel to receive the notification in real time. But well, I just wanted to show you how simple it was to send notification using pusher. Of course, you need to register your app ID, your key, your secret, all the pusher environment structure, but it's only a few lines of code of configuration. So that's how it's done, and that's how I use pusher to implement a GamePark game. So maybe Benjamin, if you have any question regarding this part.
Yeah, does the so when you update the UI for the other players,
Yes.
And you update their tic-tac-toe grids, do you update all of them in just one player message?
Yes, actually, here we play only one move. So the move is played. The grid is updated immediately on your browser. This move is sent to the server. And because it's a game with only public information, we don't have secret information, we send one message to everyone. It's only one public channel, one message, and every player and spectator will update their grids with this single message. I used this implementation. First, I used only private channels when I implemented my first games. It's a wonderful world. In this game, we have secret information. So my first implementation used only private channels. And then I refined the implementation to save pusher messages, because it's also how you charge your customers. So for all the games that does not need private channel, I implemented this new way to send messages, and this way I save messages, of course. So one message every time a movie is played.
Yeah, so so when a player plays a move, that message will only contain the one grid that he clicked on, is it?
Yes, yes, it will contain actually this data structure. And you can find it when you implement a game inside. You can run game.move in the browser console, get game.moves, and you can see the list of moves that were played since the game started. Actually, all the moves are regrouped into what is called a player action, an action as an identifier. It contains one move. So here you have the specific move, mark cell, and the player ID that did this move. Sometimes it's useful to have this. We also have consequences. That's a part that I did not cover today, but when you implement a complex game, if you play a move and the game state change suddenly from the initial state to the new state after the decision was made by the player, sometimes a lot of stuff can be going on. If you buy a card, you will spend gold, get the card, and maybe you will trigger some, immediate effect that will do another stuff. And you can have many stuff going on with one single player decision in the rules. And in that case, if the game brutally goes from state A to state B, well, the players cannot understand what is going on. And it's very hard to create the animations in the right order for everything that was going on. To solve this problem, I split the moves into very small parts. When you play a move, this move can have consequences that are also other moves. But this way, when the user interface gets the notification, you will have the move that is played by the player, which is only one single movement of material often. And then you will have the consequences inside the notification, which are all the simple movement of material that follow the rules that follow the move because of the game rules. And this way you can have nice step-by-step animation of everything that is going on in the game. We do not need that for this game, but we need that for every other game that is implemented on GamePark. So that's why we have this data structure in a player action and inside the notifications as well. But that's it. That's that's what is sent using the pusher channels when a movie is played to everyone. Everyone except the player. If you have a game with secret information, I do not use pusher to send the move played to the player himself. I use the HTTP response to send him what is going on and the consequences of his move.
Yeah. Are you using? Are you sending? I know you can get the active player with
Sorry.
You can get the current active player. You have a method for getting the current active player.
Yes.
Is that updated with pusher channels?
Oh, yes. Actually, yes, it's updated with pusher channels because, well, as we have competitive games on GamePark and you can play also with stranger, we need timers. So we have an API to, handle player time. We have you get time when it's your turn to play, and you must not run out of time, otherwise you can be ejected from the game. And I also use the the pusher notification system alongside the move. I send an update of which player is active or not, and the time they have left to play their moves. So yes, there is also this information that is sent alongside the moves or the undo actions every time a notification is sent through pusher.
Yeah, and just one last question. If someone leaves a game and then
Yes.
he joins it, how do they get, how in your other, probably, how in your other production games are they regaining the current state of the game?
Oh, when you leave the game, actually, when you display the game, so maybe I can show an example. Yeah, let's show an example. So here I can create a new game. I will create a new game of this game cry is very simple. Okay, and I need. Sorry, I don't know where it's. No, I have an issue. I cannot show you right now. But if you play the tutorial, it's yeah, I can show the interface as well. So when you load the game, you will have the game ID when it's a live game with other players. and the game state will be loaded from the current game state, which is stored in the database. So at this point, you get the game state, and you also get with the game state the current notification index that you are of the game state you are loading. And then once the pusher dev the pusher instance is connected, I will send another message to the GamePark server to retrieve any eventually missing notifications since the game state that I loaded. So that's a very interesting question, because when you connect the pusher channel, you need to retrieve the missing message if you implement a chat or something like that. In GamePark, you have a similar implementation where the game state goes alongside a notification index, and every missing notification can be retrieved later on after you are connected, so that you don't miss anything.
Yeah, it's great to hear that you've implemented.
Yeah, of course, you have a reconciliation, because if you receive any, for example, if you load the game state and you are at step 5 of the notification, and if you connect to the pusher channel and you get notification 7, you are missing notification 6. So in this case, notification 7 will just be, kept aside. Anyway, we will call the backend to retrieve any missing notification after notification 5. Then we will get notification 6 and 7 as well. And then we can reconcile everything and just display the right game state.
Yeah, that's very clever.
So yeah, that's done this way. We have and it's done for those familiar with React and Redux. I use a Redux store, so I have a huge game reducer here with my game page state. And so I have an event when the game state is loaded, and I have an event when notifications are received. And this reducer also handles when a movie is played or undone, when some action fails, or also every animation, when an animation starts and animation is complete. Every time something like that happens, the state of the application, is changing. So this game reducer, it works for every game. And this is where the logic of, handling the right way the pusher notification is done. So yeah, that's it. And that was an interesting question. It's working. It's very solid, because I have had on It's a Wonderful World nearly 250,000 games played, and I never had any issue with loading the game state from any point and missing some notifications. Those kind of issues never existed, and it was also thanks to the pusher documentation on how you can do that for a chat system, for example. I just took inspiration from there.
That's great. Great answer. Thanks.
So maybe I can go back to the slide, and I would like to speak a little bit about what we have built today. So inside the repository, you can, if you like, check out the complete rules branches, because I already implemented once all the rules of the game. There's not a lot more to do to implement that, and there's nothing else to discover regarding GamePark API. However, once the rules are complete, you still have a lot of work to complete the game, to have a game that can be deployed and played on GamePark. You need to fine-tune the user experience. You have header text, you have tutorial, display the player names, avatar, timers. Maybe you can add animations, you can add sound if you like, when you can add some pencil sound when a mark is displayed, and so on. Once all the fine tuning is done, we can deploy the game, and well, it's live. Every game is an independent GitHub repository, and every game can be implemented by one person if they like. And I'm looking for contributors, and well, it's not much, but I share the revenues of every board game which is implemented on GamePark. Right now, I don't have a wide audience, so I cannot promise, a lot of revenues from implementing a game. However, it will be shared with, fair shares for the editor of the game and for the developer of the game as well. So if you would like to contribute, you're welcome. Of course, you can contact me you can contact me by email or through the Discord of GamePark, of course. And if you want to implement a more complex game on GamePark, well, we have a brief insight, but you will have to learn about automatic moves and animations. You will have to learn the API for games with incomplete or secret information. So I already discussed a little bit about that too. You have also a specific API when you have moves with random output, for example, throwing dice, because we want to be able to replay the moves or to undo the moves. And when you undo a move, you replay all the game history to get the game state with the move undone. We need to be able to reproduce any moves with a consistent output. So there is a specific way to handle moves with random output, so that the randomness is not messing up with our replay. And well, you also have an API when you implement games with complex rules, with many game phases, and many stuff. We have a delegation pattern that is already available, so that we can split the rules in many simple parts. So get in touch if you would like to contribute. And well, of course, I would like to thank again Pesha for allowing me to stream a little bit about GamePark. That was my very first stream. I hope I was clear enough and not too boring as well. I hope my English was not too bad. And thanks a lot for following the stream. So of course, if there is any question, feel free to ask. I'm available and free to. You can answer. I can answer any question you have. So I cannot hear you, Brittany.
Brittany, I think you're on mute.
Yeah. No, I cannot hear you. Maybe, yeah.
Yeah, so well, since she has mic issues, yeah, I'll close this one out. So thank you, Romain.
You're
for
welcome.
giving us this presentation. It's been
Thank you.
really interesting to hear.
I hope you enjoyed. Well, seeing how we can use Pusher as developers. I think there's many ways to use Pusher. It was the perfect fit for my use case. So I thank you for creating this great product. It allows me it allowed me to go live very quickly when I started to implement the GamePark framework and GamePark website. It would have been much harder to implement all the core engine without pressure.
Yeah, I think one thing we often hear from people is that it's very fast to prototype and create an account with us and get something running up and quickly, and you can understand what it can do. Thank you, and I think this is it.
I use also, or maybe it can be interesting. I use also a little bit your Beams product to send notifications. Actually, when you are looking for an opponent on a game, for example, you click on you have two ways to play games on GamePark. You can play friendly games, but you need to be a subscriber for that, and you can play competitive games. But if you do so, you cannot choose your opponents, so that it's fair. So we have a matchmaking system, and if you start to look for an opponent, when an opponent is found, I use a beam notification to send a real-time notification when a game is found. And some games have only a small audience, and you can register to be notified every time another player is looking for an opponent on this game. This way, you do not have to stay, a long time behind your computer waiting for opponents. You can just say, okay, ping me when an opponent is available on this game. And it's very convenient too for some games that are not as famous as It's a Wonderful World, at least in the board game industry, so that you can find opponents as well. So I also use your Beams product for those kind of notifications.
Yeah, using Beams for matchmaking.
Yeah,
Yeah,
matchmaking,
know when the
yes.
game's about to start. Yeah, that's a good idea.
So that's it.
Yeah.
That's it about Fisher.